Good morning, ladies and gentlemen, and Dr. John Belkowitz here. We're going to be doing solving some systems of equations for you folks out there who are teaching your kids. Great job, by the way. Thank you for the questions that you sent. So this is one of those questions asked and solved. So we're going through some systems of equations here, and the first question was, why the hell are we doing this? These are one of the things that most folks say they're glad they got through it in school, but they'll never use it again. Funny enough, solving systems of equations can actually get you a job.
Well, that's what you do in engineering.
Right.
That's all
Literally.
engineering is.
So when I worked for a structural engineering firm, and we looked at the footprint of a house, and then you had your roof over it, we had to start. It was almost like watching rain fall off a roof. You had to follow the levels down to determine how, or the sizes of your joists and your girders and your beams and blah, 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 all this other stuff. And all of that was based off of the shear and moment diagrams that we're going to put in the link below. Bing! Wait, that's pointing to something else. Okay, bing! So, the shear and moment diagrams, the math behind that is all based on solving systems of equations. Two variables, and you need two equations to solve those two unknowns. So what I've done is I set up two equations here, 4x minus y equals 10, and equation number 2 is x plus y equals 5. And I wanted to go over two methods for solving both x and y. And the first one is we're going to add equation 1 to equation 2. Now it happens to be that this is already in the form for us to do it, but if for some reason we had a 5 or a 2 over here, we'd have to multiply one of these two, equation 1 or 2, to get it to the opposite of the other equation. So in our case, everything is already set up. So when we add equation 1 and 2, 4x minus y equals 10, and then we have our x plus y equals 15. So when we add those two, I'm sorry?
Equals 5.
Oh, I'm sorry. Thank you so much, love. We end up getting 5x, the y's cancel out, plus 0 equals 15. So we end up with x equals, as Whitney said, 3. Now, we have x equals 3. We can, let me go ahead and erase this. So we have x equals 3. Now what we can use is one of our equations, 3 plus y equals 5. We substituted our x for 3. Y equals 5 minus 3. And then, of course, y equals 2. Boom! Boom, shakalaka. Okay, so then we solve. Right? So now we know that x equals 3, y equals 2. So if we solve for, let's say, equation 2, 3 plus 2 equals 5. Check. And then let's go ahead for equation number 1. 4 times 3 minus 2 equals 10. 4 times 3 is 12, minus 2 equals 10. Check. Okay, so that's method 1. Now, you don't necessarily have to do this. You remember that last time I spoke about Richard P. Feynman, and he said, math is just about solving, finding the end result. To be quite frank, it doesn't matter how you get there, just get to that end result, whether you use arithmetic or algebra. But let's go ahead and look at this method number 2. So method number 2, we're going to set one equation equal to one variable. I'm going to take equation number 2, and I'm going to set it equal to x. And to do that, I have x plus y equals 5. If I subtract y from both sides, my y cancel out here, that's 0. So x equals 5 minus y. Oops. Now, one thing you'll find with all these methods is that they do require a bit of accountability. And that's where folks get really hung up the most. It's just a pain in the ass to do this. So I'm going to take my equation number 2 the x version of it, and I'm going to substitute it into my equation 1. So I have 4 times 5 minus y equals 10, right? So that means I have 4 times 5 is 20 minus 4y minus y equals 10. 20 minus 2y equals 10.
You need a 4 there.
Oh, there's a 4 there? Ooh. So I guess this is 5, huh? Thanks, baby. See, Whitney's the best. She just helps me out with everything. So I'm going to subtract 20 from both sides. That's 0 out. I'm going to subtract 20 here. That gives us a negative 30 or...
Negative 10.
Negative 10. Thanks, Whitney. So what we're left with is negative 5y equals negative 10. Thank you, Whitney. So negative 5 cancels out. Negative 10 over negative 5. Y equals 2. Okay, so we had y equals 2, which I believe we got before.
Yep.
But let's go ahead and plug that back into equation number 2. X plus 2 equals 5. Subtract 2 from both sides. Minus 2. X equals 3. Okay. Again, wonderful job, folks. Let us know what other math questions. Whitney's going to set up some new thing with Haley.
Ask John B or something like that, to where
Okay.
you can just ask like a live question
Right.
and John can solve it or
Wicked.
answer it.
Wicked. I don't think we have any. Oh, there are 2 people watching. So maybe we can change this equation up and do one more, and I'll solve it using the other method. So I think I'm going to use method number 1. Take equation number 1 and add it to 2 times equation number 2. Okay? So I have equation number 1, which is 2x plus y equals 12. So that's equation number 1, and I want to add that to equation number 2 times 2. So that means, I'm going to take this in. I've got negative 2x plus 6y equals 20. Right? So my first shtick over here, what's that called? My x's cancels out. Now I have 7y equals 32. Seriously?
I'm sorry.
Really? No. We're going to go with it. We're going to go with it. So, 7y really equals 32. We're going to divide 7 both sides. Good Lord, love.
Sorry.
Y equals 32 over 7. So, 32 over 7. So, 5 times 7 is 35. 4 times 7... No.
Come on.
No, stop. 27 or 28 divided by 7 is 4.
Yeah.
So, it's somewhere between 4 and 5.
Right.
You know? Okay, folks, we're doing it. 7 divided by 32. Come on, this is a class. So, I think it's somewhere between 4 and 5. So, first we got 4. So, that's 28. That's 40. So, that's 42 is 6. So, we've got to go with a 5 here. So that's 35. Oh, look, I got it off the page. So here, we got 40 minus 35 is going to be 50. So that's going to be 0.7.
4.57.
What?
No,
40
45.7. That
That-
would be 4.57.
Oh, 4 thank you so much. 4.57. Thank you, my love. So 49.10. Let's just
I think that's plenty.
chop it off over there. So, thanks. Hey, I was pretty close when I said
You
it was
were
approximately 4.5. So why don't we say 4.6? Thanks, Whit. So we have y equals... Lordy.
Well, you asked me to just
4.6.
throw it
X
down.
equals... Question mark. Yeah, but I thought, you were going to do that in your head. Anyway... So let's go ahead and throw that back into equation number 1 for the love. 2x plus 4.6 equals 12. So we're going to subtract 4.6. Don't you dare pull out that calculator. That goes to 0. We do the same to both sides. So that's going to be, was that 7.4?
Right.
So, good Lord. 2x equals 7.4. Divide 2 by both sides. These cancel out. And then we're left with x equals 3.7. Okay, so x equals 3.7. And remember, you know, if you were ever to ask the question, when the hell am I ever going to use this? This is what civil engineers do, especially those who are doing structural design. Either they do this or a version of this every flippin' day. So there is a freaking occupation here. So we're going to go with equation number 2 since we've been going with equation number 1. Why not, right? Negative 3.7, really? Plus 3 times 4.6. Don't you dare stop that. Stop it. No. I don't want that. Come on, equals 10. Like, listen, it's okay. So we got negative 3.7. We don't have to do anything with that. Let's go ahead and multiply 4.6 times 3. So that's 8. You got the 1 up there, 13.8. So we have 13.8. So negative 3.7 plus 3.8 equals 10. Well, yeah, it's somewhere around 10.1 is approximately 10. So I'm going to call that a check. And it really was, you know, in this error, my rounding error here. So if I carried the math all the way through, then it would have worked out perfectly. But hey, you know. So thanks for joining us. Don't forget to ask any question out there, even if it is solving fractions in our head. We do that for you. The next time we get on here, we're going to be doing some chemistry and biology. And guess who's going to be hosting that?
Haley.
Nope, it's going to be Whitney. So awesome. All right, y'all have a great weekend. Stay safe out there. Let us know if you have any questions. Go Concrete.
Beat asphalt.